Now let's go a little further and consider the interference pattern we would get if there were 3 equally spaced slits rather than 2. We add in a third electric field, E3, so that there is the same phase difference between E2 and E3 as there is between E1 and E2. We won't work through it, but what you find is that there are 2 levels of maxima now. The highest points are called primary maxima, and they occur at phase differences that are multiples of 2 pi. But there will also be smaller maxima called secondary maxima in between the primary ones. They occur for phase differences of odd multiples of pi. Then there are minima that occur in between each maximum at phases of multiples of 2 pi over 3. And that makes the shape of pattern that you see here. So you see in this diagram the intensity graphs for several different numbers of slits. For each number, the maximum electric field is n times the value for a single slit, and so the maximum intensity is n squared times the single slit intensity. You can see changes as the number of slits increases. The primary maxima become brighter and narrower, and the number of secondary maxima becomes bigger, but their relative intensity becomes less and less. This trend ends up with the diffraction grating that we treat as an infinite number of slits of equal spacing. I want you to predict now what the interference pattern would look like from a very large number of slits.